equation, we have to evaluate the definite integral x plus 1 into dx from 0 to 5 as the limit of sums. Let's begin with the solution. And we have integral of x plus 1 into dx from 0 to 5, and we have to find its value using the limit of sums. Now, by the definition of integrals as limit of sums, we know that integral of fx into dx from a to b is given by b minus a into limit of 1 upon n as n approaches to infinity of the function f of a plus f of a plus h plus so on up to f of a plus n minus 1 into h. And here h is equal to b minus a upon n, and this tends to 0 as n tends to infinity. Now here b is equal to 5, a is equal to 0, so this implies h is equal to 5 minus 0 upon n, so this is equal to 5 upon n, and the function fx is equal to x plus 1, so this implies that f of a is equal to a plus 1 and a is equal to 0. So we have f of 0 is equal to 0 plus 1, that is 1. Further, this implies that f of a plus h is equal to a plus h plus 1, and this implies that f of 0 plus h, since a is 0 and h is 5 upon n, so this is equal to 5 upon n plus 1. Similarly, we can find f of a plus 2h. This is given by a plus 2h plus 1. So f of 0 plus 2 into h is equal to 2 into h, that is 2 into 5 upon n, which gives 10 upon n plus 1. And finally, let us find f of a plus n minus 1 into h. This is given by a plus n minus 1 into h plus 1. So this implies f of 0 plus n minus 1 into h is equal to n minus 1 into h is 5 upon n plus 1. Therefore, integral of fx into dx, that is x plus 1 into dx from 0 to 5 is given by, first we have b minus a, that is 5 minus 0, which is 5, then limit as n approaches to infinity of 1 upon n, then inside the bracket we have f of a plus f of a plus h plus 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 so on up to f of a plus n minus 1 into h. So f of a is f of 0, that is 1, plus f of 0 plus h, that is 5 upon n plus 1, then f of a plus 2h, that is 0 plus 2h is 10 upon n plus 1 plus so on up to n minus 1 into 5 upon n plus 1. This further implies that 5 into limit as n approaches to infinity 1 upon n into, now here 1 is n times, so we have 1 into n plus taking 5 upon n common, we have 1 plus from here we get 2 plus so on up to, from the last time we get n minus 1. This is further equal to 5, limit as n approaches to infinity 1 upon n into n plus 5 upon n. Now the sum of first n minus 1 terms is given by n minus 1 into n minus 1 plus 1 divided by 2. This is equal to 5 into limit as n approaches to infinity of 1 upon n into n plus 5 upon 2 into n into n minus 1 divided by n. So this is equal to 5 into limit as n approaches to infinity 1 upon n, taking n common, we have 1 plus 5 upon 2 into n minus 1 upon n, and this is equal to 5. Limit as n approaches to infinity, these two cancel out, and inside we have 1 plus 5 upon 2 into 1 minus 1 upon n. Now taking limit inside, we have 5. Now limit as n approaches to infinity, 1 is equal to 1 plus 5 upon 2. Limit as n approaches to infinity of the function 1 minus 1 upon n, and this is equal to 5 into 1 plus 5 upon 2. From here we get 1 minus 0, since limit as n approaches to infinity 1 upon n is 0, and this is equal to 5 into 1 plus 5 upon 2, that gives 7 upon 2, and this is equal to 35 upon 2. Therefore, integral of x plus 1 into dx from 0 to 5 is equal to 35 upon 2. This completes the solution.